Group 2 elements, alkaline earth metals. Group 2 consists of beryllium, magnesium, calcium, strontium, barium and radium. Radium is radioactive. Beryllium the first member, hence group 2 is also known as beryllium family. All the group 2 elements show similarity in their behavior because of similar electronic configuration. They have a general electronic configuration NS2, 2 valence electron. So they have got a noble gas configuration. After the noble gas configuration, outermost shell with 2 electron, NS2 electronic configuration. Because of similar electronic configuration, all these group 2 elements show similar chemical properties except the first member. We know the first member, beryllium, show properties different from the other members of the group. That means beryllium show anomalous behavior and beryllium show diagonal relationship to aluminium. Second member of group 13, that is aluminium. Beryllium and aluminium show similarity in the properties, which is called diagonal relationship. If you write the electronic configuration of group 2 elements, beryllium has the electronic configuration after helium configuration 2s2. Magnesium after neon configuration 3s2. For calcium has after the noble gas argon configuration after 4s2. Strontium has 5s2 configuration after noble gas krypton. Barium has 6s2 configuration after noble gas xenon. And radium has configuration of radon after 7s2. So general electronic configuration of group 2 elements is NS2. There are 2 valence electrons. And these elements are also known as alkaline earth metals because the oxides and hydroxides of these metals are alkaline in nature and they are found in Earth's crust. So these elements, these group 2 metals are also very reactive as alkali metal, not as reactive as alkali metal, but they too are reactive because they contain only 2 valence electrons. Only 2 electrons in their valence shell and they readily donate those 2 electrons. So they too are reactive metals. Atomic and ionic size. Atomic and ionic size of group 2 elements. When we compare with the alkali metal and the alkaline earth metal, means group 2 elements have, when we compare the size with the group 1, we studied group 1 elements have the largest size in a period. If you take a period, we know from left to right along a period, atomic size decreases. So group 1 elements have the largest size. That means group 1 elements are larger than group 2 elements in a period. Because from when we move from left to right in a period, atomic size decreases. But compared to other elements in the periodic table, group 2 and group 1 elements are larger in size. And down the group atomic and ionic size increases. Now, ionization enthalpy. The variation of ionization enthalpy. Ionization enthalpy denoted as delta Hi. It is the energy needed to remove the most loosely bound electron, that is the valence electron, from an isolated gaseous atom. When we compare the ionization enthalpy of alkali metals, that is group 1, with the ionization enthalpy of alkaline earth metals, which is having higher ionization enthalpy. Alkaline earth metals, the size we have already compared, alkaline earth metals have smaller size. Alkaline earth metals are small. They have small size than alkali metals. Because of small size, their ionization enthalpy values are greater. alkaline earth metals have larger ionization enthalpy than alkali metals. This is because of their small size. Alkali metals are larger and hence easy to remove. The process of removal of the valence electron is more easy compared to the corresponding alkaline earth metal. So alkaline earth metals have ionization enthalpy higher than those of the corresponding alkali metal. Down the group ionization enthalpy decreases. Down the group delta Hi value from beryllium to radium, delta Hi value decreases. This is due to increase in the size. Down the group atomic size increases, nuclear attraction on the valence electron decreases, hence ionization enthalpy decreases. So the decrease in the ionization enthalpy can be explained. Down the group atomic size increases, nuclear attraction on the valence electron decreases. As the size from the distance from the nucleus increases, nuclear attraction on the electron decreases. Therefore, ionization enthalpy decreases down the group. When we coming to the hydration enthalpy, that is the energy released during hydration. Hydration enthalpy. What is hydration enthalpy? It is denoted by delta HYD, enthalpy of hydration or hydration enthalpy. It is the energy released during hydration of an ion. So these all alkaline earth metals lose 2 electrons, they contain 2 valence electrons, they lose 2 electrons and form divalent ions. Beryllium form Be2 plus ion. Magnesium form Mg2 plus ion. Calcium 2 plus. Barium 2 plus. Strontium 2 plus. Etc. When we compare the hydration enthalpy of these ions, hydration enthalpy depends on size of the ion. How hydration enthalpy vary with the size? Inversely proportional. Smaller the ion, higher the ionization enthalpy. That is, when size of the ion decreases, hydration enthalpy increases. So which is the smallest of these? Beryllium. Beryllium 2 plus is the smallest. So highest hydration enthalpy for beryllium 2 plus. Beryllium 2 plus salts are mostly hydrated. More hydrated than Mg2 plus, than Ca2 plus, than strontium 2 plus, than barium 2 plus. This is because ionic size down the group increases. With the increase in the ionic size, hydration enthalpy decreases. The hydration enthalpies of alkali metal and alkaline earth metal, group 1 and group 2, when we compare, which is smaller? Group 2 metal ions are smaller. These are larger. So which is having higher hydration enthalpy? The smaller. Alkaline earth metal ions have hydration enthalpy, delta H hydration, greater value for alkaline earth metals because of their small size compared to alkali metal ions. So alkaline earth metal ions are more hydrated than alkali metal salts. For example, magnesium chloride exists as MgCl2 6H2O, hexahydrate. Similarly, calcium chloride exists as CaCl2 6H2O. Whereas sodium chloride and potassium chloride, the corresponding members in the alkali metal series, sodium chloride, potassium chloride do not form such hydrates. Alkaline earth metal salts are more hydrated than alkali metal salts, because alkali metal ions have larger size, alkaline earth metal ions have smaller size. Now coming to the physical properties of alkaline earth metals. Generally, they are all silvery white in color, lustrous, shiny appearance. You all may be familiar with magnesium ribbon. Silvery white in color, lustrous, relatively soft. But when we compare the hardness of alkali metals and alkaline earth metals are smaller size. They contain more number of valence electrons, so stronger metallic bonding in the case of alkaline earth metal, group 2. So alkaline earth metal group 2 elements are harder than alkali metals. So they too are relatively soft. Both alkali and alkaline earth metals are soft metal, but harder metals are alkaline earth metals because they contain more number of valence electrons, stronger metallic bonding in group 2 elements. Melting and boiling point. Melting point and boiling point, if you compare with group 1 and group 2, we told group 2 elements are harder and melting and stronger metallic bonding in the case of group 2. Hence, melting and boiling point also higher for group 2 elements than group 1. Now, the behavior towards flame. So, these elements, alkaline earth metals, only 2 valence electron. They readily lose that 2 valence electron. The energy from the flame is enough to excite these electrons to higher energy level. That means when alkaline, like alkali metals, alkaline earth metal salts also, when shown in flame, give characteristic color. That is called flame test. The first 2 member, that is beryllium and magnesium. Beryllium and magnesium do not give any color. They do not give flame test. Means do not give any color in the flame. Cannot be detected by flame test. But the other elements, calcium salts show brick red color in the flame. Barium salts are pale green or apple green color in flame. Strontium is crimson red color. Strontium salts show crimson red color in the flame. So when we show these metal ion salts in the flame, the heat of the flame will excite the valence electrons present in these metal ions to higher energy level. When the electron comes back to the original level, they emit energy. That emitted energy corresponds to brick red region in the case of calcium, pale green region in the case of barium, crimson red region in the case of strontium. But beryllium and magnesium do not show flame test. They do not give any color in the flame. This is because these 2 metal ions are small in size, small size. And the valence electron in these metals are more attracted to the nucleus because of their small size. So the valence electrons are strongly bound to the nucleus. So the heat from the flame is not enough to excite the electrons present in beryllium and magnesium to higher excited state, higher energy state. So they do not give any color in the flame test. The other 3 elements, calcium, strontium and barium, can be detected by flame test. Now, chemical properties. Chemical properties of alkaline earth metals. Like alkali metals, alkaline earth metals are also very reactive. But the reactivity of alkaline earth metals less than the reactivity of alkali metals. First, reactivity towards air and water. All alkaline earth metals react with the atmospheric oxygen. They also react with the atmospheric nitrogen to give corresponding metal oxides of the general formula MO. They react with nitrogen and give metal nitrides with the general formula M3N2. For example, beryllium, when react with oxygen, we get beryllium oxide, BeO. Magnesium with oxygen gives MgO. Calcium with oxygen gives calcium oxide, etc. And these elements react with the nitrogen of the air, in the air. Beryllium, when react with nitrogen, it forms beryllium nitride of the formula nitrogen valency 3, beryllium valency 2. Magnesium react with the nitrogen and form magnesium nitride, Mg3N2. Calcium with nitrogen gives calcium nitride, Ca3N2. But the reaction rate of beryllium and magnesium with oxygen and nitrogen is very slow. This is because of the formation of an oxide film on their surface. So there would be an oxide film formed on the surface of beryllium and magnesium, so that film prevent the further reaction with the atmospheric oxygen and the nitrogen. So the reaction rate of beryllium and magnesium with the atmospheric air is kinetically very slow. Speed of the reaction is very small. Means these two are kinetically inert to oxygen and the nitrogen. These elements react with alkaline earth metals, react with water and form corresponding hydroxide. For example, beryllium in water gives beryllium hydroxide. Magnesium in water gives magnesium hydroxide. Calcium gives calcium hydroxide. Barium gives barium hydroxide. Strontium hydroxide. But here also beryllium and magnesium are kinetically inert to reaction with water because of the formation of oxide film on their surface. Now reactivity towards hydrogen. Alkaline earth metals react with the hydrogen and form hydrides, except the first member beryllium. That is, for example, magnesium on heating with hydrogen form magnesium hydride of the formula MgH2. Similarly, the other elements also, but beryllium hydride is not formed by this method. To prepare beryllium hydride, we carry out another reaction, that is beryllium chloride is treated with the lithium aluminum hydride. This reaction gives beryllium hydride, lithium chloride and aluminium chloride. All other alkaline earth metal hydrides can be made by heating the metal with hydrogen. Now reaction with halogens. Alkaline earth metals react with halogen and form, if M is an alkaline earth metal, they react with halogens like fluorine, chlorine, bromine, iodine and form metal halides of the formula MX2. For example, magnesium plus chlorine gives MgCl2. Reactivity towards acids. Alkaline earth metals react with acid, for example hydrochloric acid, they form salt. Metal chloride salt plus hydrogen gas. They react with acids and form salt, and hydrogen gas will be liberated. These elements have strong tendency to lose their electron. That means they are electron donors. Substances which donate electrons are reducing agents. So alkaline earth metals like alkali metals are strong reducing agents. And the first member is beryllium. Beryllium shows some of the properties different from the other members. All the other alkaline earth metals mainly form ionic compounds except beryllium. Beryllium compounds are mostly covalent in nature. This is because of small size of beryllium. The first member, beryllium, is small size, large charge to radius ratio, and it has got high ionization enthalpy. Ionization enthalpy down the group decreases, so the first member has the highest ionization enthalpy. It has the highest electronegativity. Because of these reasons, the first member, beryllium, show anomalous behavior from the rest of the members. And beryllium shows similarity to aluminium, diagonal relationship. Now some of the uses of these group 2 elements. Beryllium is used in the manufacture of alloys. Magnesium is also used for making alloys with the aluminium, zinc, manganese, etc. Magnesium aluminium alloys are light. Hence, they are used in aircraft construction. Magnesium hydroxide. A suspension of magnesium hydroxide in water is called milk of magnesia. Milk of magnesia is used as an antacid. It's a medicine. Milk of magnesia to reduce acidity. Magnesium carbonate is used in toothpaste. It's an ingredient of toothpaste. Calcium is used in the extraction of metals. Calcium and barium are used to remove air from vacuum tubes. Radium, we know this is radioactive. This is used in radiotherapy. In the treatment of cancer, radium is used. So these are some of the uses of alkaline earth metals.